What's your dream university?
Stanford,
Oxford, LSE,
McGill,
Cambridge. What about you?
NUS。
迈向世界名校的阶梯，首选辅仁国际学校。
Good morning, everyone. I'm Srian Bin from FIS. So today I will present it to you for the complex number, the null site chapter. Next. So what is so-called a null site? As you can see, right, from the general formula, modulus of z minus a plus bi is equal to r. That means what? We are trying to see how this point will move. So if you according to what we learned for our modulus, we are trying to find out the distance between z and AB, which the distance is equal to r. So I need you to think of it. How you are going to find out all the points z such the distance from AB is equal to r? The answer is obvious. You can see from it here. It's going to be a circle. Right. So for this circle, we are going to have the center AB, which you are going to use the r as the radius. After that, you are going to draw on a circle. This will be the null site of our z. So we are going to see an example from the next PPT slides. So as you can see from the first example here, we are going to have modulus of z minus 1 minus I is equal to 1. First of all, you need to convert it into the standard formula, which I need to make it become z minus a plus bi. So first of all, you can see, right, we need to change into z minus 1 plus I is equal to 1, which you can see from our standard formula there. The center has to be at 1, 1, and the radius is equal to 1. So first of all, you are going to locate the 1, 1, this point as the center. Then you are going to measure for 1 as the radius. After all, you draw on a circle. It will be the null site of this equation. So now we take a look of the second equation there. It might be a bit of confused for you for your right hand side. Because your right hand side, you are going to see a modulus 2i instead of a constant value for you. So in this case, what should you do? I still need you to recall how we are going to find out for the modulus. Because modulus of 2i, if we are using the modulus formula, it was just simply converted to 2. So in this case, you should be able to find out our center is a negative 2 and 3, while the radius is equal to a 2. So for you to draw out for this diagram, you just look at the graph. We are going to locate the center. After that, we draw out the radius, which is equal to 2. Overall, you are going to form a circle, which you should be able to find out the null site of this equation. Now we are going to see another null site from another standard formula here. Okay, we take a look. Next. So you should be able to see for the next equation, which is a bit different from your first equation. The difference is, if you look at the right hand side there, the right hand side for our first equation is about a r, which is going to be a constant value. But now if you look at our right hand side, now it's still a modulus. Modulus of z minus a2 plus a b2i, which we are trying to find out all the points z, which the distance from a1, b1 and the distance from a2, b2 are equal. That means we need to find out the point which is equal distance from these two. Can you do a recall? How can we find out the point which is equal distance from other 2 points? The keyword is perpendicular bisector, right? So in order to draw out the perpendicular bisector, first of all, you need to identify for these 2 points. Later on, you are going to connecting these 2 points, draw out the perpendicular bisector as the diagram shown, so your task will be complete. Now we move to another 2 examples for you to have a better understanding of this part. Next. So you should be able to see from the examples here. First of all, modulus of z minus 1 minus I is equal to modulus of z minus 2 minus a 3i. So of course, still remember that we need to convert it into our standard formula before you are able to draw out the null site. So first of all, we need to make it become z minus a plus bi. So as for your first part, we need to change it into z minus 1 plus I. And for your second part, we need to convert it into z minus 2 plus 3i. So once it's in the standard formula format, Now you can able to identify it's going to be a perpendicular bisector. For you to draw out this perpendicular bisector, again, we need to find out for these 2 points first. So you should be able to see from the standard equation there, these 2 points, one point is 1, 1, and another point is 2, 3. So after you plot out for these 2 points, use a dotted line to connecting these 2 points. After that, you draw on the perpendicular bisector. Therefore, this question it is done. Alright. Then if you look at our second example here, modulus of z plus 2 is equal to modulus of z minus 4i. This could be a bit confusing for some of you because you are not going to see a complete complex number here. But I need you to recall what we have done. For complex number, it could be purely real or sometimes it could be purely imaginary. So no need to worry about it. You just need to still go and change it into the standard form. So first one, even it's a z plus 2, we can write it as z minus negative 2 plus a 0i, which means the imaginary part is equal to a 0. Similarly, for the second part, you can change into z minus 0 plus 4i, which real part is equal to a 0. So when you are able to identify these 2 points, actually these are 2 special points. One will be on the real axis, another part will be on the imaginary axis. So once you identify from these 2 points, still use a dotted line and draw on the perpendicular bisector. Therefore, it will be the null side of this equation. So that is all for my presentation. Hope to see you next time.